What specific problem does your proposed method, ROICtrl, aim to solve in the realm of text-to-image generation? Please explain the motivations behind it.
ROICtrl aims to address the challenge of effective instance control in text-to-image generation, specifically the issues of spatial alignment and attribute leakage when generating images with multiple instances. Current methods struggle with accurately controlling the spatial positions and attributes of instances due to the limitations of using natural language alone, which often leads to linguistic ambiguity. ROICtrl introduces the ROI unpool operation, which allows for explicit and efficient ROI injection, enabling the model to restore cropped features to their original positions on high-resolution feature maps. This method enhances the ability to generate images with complex compositions by allowing independent control of each instance while maintaining high spatial fidelity. The motivation behind ROICtrl is to improve the generation quality and efficiency of multi-instance images, leveraging the strengths of existing diffusion models while overcoming the limitations of prior implicit and explicit instance control methods.
How does the ROICtrl method work? Illustrate the core steps involved in the implementation of ROI unpool and how it integrates into the overall architecture of ROICtrl.
The ROICtrl method integrates instance captions into diffusion models by utilizing a novel operation called ROI unpool, which is essential for effective instance control in visual generation. The core steps of ROI unpool involve restoring cropped region of interest (ROI) features back to their original positions on the high-resolution feature map, allowing for detailed decoding of fine-grained visual elements. Specifically, ROI unpool reconstructs spatial features by sampling from the nearest grid points of the ROI features, addressing the challenge of pasting back variable-sized ROIs while avoiding redundant computations associated with masked attention mechanisms. In the overall architecture of ROICtrl, ROI unpool works in conjunction with ROI align, which extracts ROI features and is followed by a learnable blending mechanism that fuses global and instance attention outputs. This integration enables ROICtrl to achieve improved spatial alignment and regional text alignment, facilitating the generation of complex images with multiple instances described by freeform text.
Can you provide a simple illustrative example that demonstrates how ROICtrl manages to control multiple instances in an image generation task? Walk through the example step by step, detailing how the instance captions and bounding boxes are used.
In an image generation task using ROICtrl, consider the scenario where we want to generate an image of a park scene containing a red ball and a blue teddy bear. First, we provide a global caption, such as "a sunny day in the park," which describes the overall composition. Next, we define instance captions for each object, red ball for the ball and blue teddy bear for the teddy bear, along with their corresponding bounding box coordinates that specify their locations in the image. During the generation process, ROICtrl utilizes the global caption to establish the background context, while injecting the instance captions into their respective regions, using the ROI align operation to extract features specific to the bounding boxes. The refined ROI features are then placed back into their original positions on the high-resolution feature map using the ROI unpool operation. This step ensures that the details of each instance are accurately represented in the final image, allowing for independent control of the red ball and blue teddy bear without attribute leakage, resulting in a coherent and detailed image of the park scene.
What are the main theoretical and practical benefits that ROICtrl offers compared to previous methods for instance control? Please discuss improvements in efficiency, accuracy, and any notable enhancements.
ROICtrl offers significant theoretical and practical benefits over previous methods for instance control, primarily through its innovative use of the ROI unpool operation, which allows for efficient and accurate ROI injection. This method enables explicit extraction and processing of ROI features while maintaining computational costs independent of the original feature size, thus enhancing efficiency. In terms of accuracy, ROICtrl achieves superior spatial alignment and regional text alignment, outperforming prior methods like instance diffusion and MIGC, particularly in generating small objects and managing occlusions effectively. Notably, ROICtrl's compatibility with both spatial-based and embedding-based add-ons ensures seamless integration and flexibility in multi-instance generation, addressing the severe attribute leakage issues seen in earlier approaches. Additionally, the introduction of ROICtrl Bench provides a comprehensive evaluation framework that emphasizes freeform instance captions, further enhancing the model's applicability in real-world scenarios.
How did you validate the effectiveness of ROICtrl? Describe the experimental design, datasets used, benchmarks and metrics for performance evaluation, and how these help demonstrate the method's capabilities.
The effectiveness of ROICtrl was validated through a comprehensive experimental design that involved training on the MS-COCO dataset, which consists of 118K samples using freeform text captions generated by CogVLM. To evaluate ROICtrl's performance, we introduced ROICtrl Bench, a benchmark specifically designed to assess both template-based and freeform instance captions across 4 tracks, allowing for a broader evaluation of instance control capabilities. Performance metrics included spatial alignment, measured by mean intersection over union, MIOU, and regional text alignment, assessed through accuracy rates using Mini-CPM v2. 6. Additionally, ROICtrl was compared against existing benchmarks, such as MIGBench and InstDiffBench, demonstrating superior performance in generating small objects and maintaining better spatial and regional text alignment. This rigorous evaluation framework effectively showcased ROICtrl's capabilities in multi-instance generation and its compatibility with various community models and add-ons.
In your results, you mentioned that ROICtrl outperformed existing methods. Can you provide specific quantitative results or findings that highlight the performance improvements achieved with ROICtrl? What limitations did you observe during your experiments?
In our experiments, ROICtrl demonstrated superior performance compared to existing methods, particularly in generating small objects, as evidenced by the quantitative results in Table B, where it achieved better spatial alignment and regional text alignment. Specifically, ROICtrl outperformed both instance diffusion and MIGC, with a mean intersection over union MIOU of 0.652 on ROICtrl Bench, indicating precise localization of small objects and reduced quantization errors. However, we observed that ROICtrl performed slightly worse than instance diffusion on out-of-distribution subjects, likely due to the latter being trained on a larger internal dataset. Additionally, while ROICtrl maintained better global consistency and reduced attribute leakage compared to GLIGEN and MIGC, it still faced challenges with spatial alignment when applying pre-trained cross-attention directly to ROI features without refinement. Overall, while ROICtrl achieved state-of-the-art performance, the limitations in handling out-of-distribution instances and the need for ROI self-attention refinement were notable.